Hello, sir.
You can mute your mic. I welcome actually our another doctoral committee member, Dr. Navjot, and Dr. Surya Prakash has joined. So probably Dr. Anjali must be joining. So let us check for 1 or 2 minutes more. Then we can start.
Sir, good evening, sir.
Dr. Navjot, should we start or should we wait for two members are still to be joined, Dr. Anjali and Dr. Anant Mohan?
As you say, sir, it's fine with me.
Okay. So I have just calling Dr. Anjali if she can join.
Hello.
Okay, Dr. Anjali told me that she is just joining, so just wait for 1 or 2 minutes, then we will start. Still 1 minute is there, so probably because we have written 3:30 as the time. In my watch, it is 3:29. So let us wait for 1 more minute. So, Dr. Asadi, I think you may join. I think you may start because it is already 3:30. So you may
Yes.
start presentation. Okay.
Yes, sir. Thank you, sir.
Try to complete in 45 minutes to 50 minutes. Huh?
Yes, sir. Yes, sir. Thank you, sir. Good evening, respected Supervisor Sir Anupam Agrawal sir, and Surya sir, and Navjot sir, and Anjali madam, and Anant sir. This is Asadi Srinivasulu, PhD scholar, under the guidance of Anupam Agrawal sir. I have chosen the title Deep Learning Driven Generative AI Decision Support for Viral Disease Detection and Analysis. I have collected 56,000 chest X-ray and CT scan images. I have applied hybrid deep learning and generative AI techniques with a combination of various proposed frameworks I have integrated, and I have implemented in this sixth semester, and I'm giving presentation for fifth and sixth semester colloquium. And the last meeting was held on 6/3 and 2025 March. That time, all the committee members given suggestions. I incorporated all those suggestions. I will show those comments, answers at the end of the presentation. And before that year, July 25th, 2024, the colloquium happened, and I have implemented all that queries. And before that, 30th December 2023, colloquium happened, and I got queries from the committee members. I have incorporated all those things. And these are the contents I would like to explain: abstract, introduction, literature review, proposed system and methodology, experimental results and analysis, discussion of results, conclusion, and future work and references. So same thing I have incorporated. These are the chapters in my thesis writing. These are the viral diseases I have explained last time. Top 10 viral diseases like COVID-19, influenza, HIV, hepatitis B and C, dengue, Zika, Ebola, measles, MERS. These are the top 10 viral diseases. And what are the solutions? What is the primary diagnostic tools? What are the key symptoms and affected regions? Current diagnostic challenges? What are the potential AI and deep learning solutions? I have considered all these symptoms for my thesis. And coming to abstract, in this research, I have used a hybrid model called Deep Learning and Generative AI Decision Support Framework for accurate multi-class classification. I'm classifying chest X-ray and CT scan images as 3 categories, like COVID-19, pneumonia, and normal cases. And by applying this hybrid deep learning generative AI technique, I got after a generative augmentation achieving stable convergence on 56,000 images on benchmark data sets I have verified, and I got 97.8 accuracy. And this proposed system, we are performing challenges like class imbalance and heterogeneity across various types of imaging modalities. And these frameworks I have achieved. I have applied nearly 8 combination of techniques in this hybrid model, and I got 97.8 accuracy. And still I'm working on to improve this accuracy by increasing size of the data, by increasing various fine-tuning parameters like activation function, dropout function, and various the size of the data, and a few more parameters I'm considering. And these are the keywords I have identified for my research. And these are the 5 methodologies under deep learning generative AI decision support framework I have incorporated, like first methodology, I'm finding severity detection using CNN and RNN. Then second methodology, generative AI for viral disease prediction. And third methodology, vision transformer and generative adversarial network-based data augmentation for viral disease detection. And the fourth one is explainable AI and self-attention-based deep learning for viral disease detection. And finally, federated learning for privacy-preserving viral disease detection. These 5 methodologies, I'm combining it as a hybrid model called a DL, Generative AI Decision Support Framework Hybrid Model. So introduction, I have taken this virus. Early prediction is very important for human being. So that's why I'm choosing this viral disease prediction detection by using this hybrid model on various categories like COVID-19 virus, pneumonia, influenza, hepatitis B and C. I have taken 3 types of data sets like text data I have checked, then chest X-ray images, CT scan images. By the conditions on lungs, heart and the surrounding structures, I have taken as a chest X-ray and the CT scan images. I have collected benchmark data sets. And this is the AI integrated pipeline for precision, different data sets we are checking with the high dimensional data sets like 56,000 images I have taken into the account. Then learning methods like deep learning and generative AI, federated learning, various explainable AI I have integrated in these learning methods. And finally, I am getting outputs, data analysis and visualization. Finally, I am taking the decision which classification is having more positive and negative. So these are the challenges. Viral disease detection is a challenge due to data scarcity, and in the existing system, they have used limited data sets. And I'm combining on CT and chest X-ray images by using a hybrid model with the combination deep learning models, generative AI augmentation, multimodal analysis, and finally we are getting whether the X-ray or CT scan image is positive or negative. And by proposing deep learning generative AI decision support, I have increased accuracy on that existing benchmark data sets. And I have collected nearly 200 literature survey papers from reputed journals. These are the reputed journals I have collected. And from existing research, they have used traditional models, machine learning, deep learning, CNN, RNN. But I am combining all these latest extensions and latest technologies in artificial intelligence, including generative augmentation, federated learning, explainable AI. And I have used a few more models by implementing my research papers. I have incorporated various models. In deep learning, I'm using Python programming. There I have used TensorFlow, Keras, scikit-learn, including with these are my proposed models I have incorporated on high dimensional data sets by computing high computational. There are some challenges I have identified. To overcome those challenges, I'm showing samples of 20 literature survey papers. Like this, I have collected authors, limitations, existing method, proposed approach, data sets they have used, and the techniques what they have applied, and what are the tools they have used, and what are the validation metrics, and the future direction references. To overcome these drawbacks, I'm using a hybrid model. According to Kai and his team, they have developed a research paper. In this research paper, I have taken drawbacks like limited generalizability, data dependency, complexity and implementation. And same way, Anastasia and his team developed one more paper on viral diseases. So from that paper, They have used CT scan images. I have collected drawbacks like limitations on COVID-19 detection, less accuracy by applying machine and deep learning techniques, and challenges. It supports support vector machine. From the third paper, Jamsheddy and his team, they have applied LSTM and GANs. And from that research paper, I have identified limited validation and benchmark data sets and interdisciplinary gap, data privacy and ethics. And in the fourth paper, Rahman and his team, they have also implemented on COVID-19. In this paper, they have used dataset X-ray based and have identified limited scope, real-world applicability, accuracy metrics, and data privacy. And Ajagbe and his team, from that paper, I have identified, they have used Kaggle and GitHub repositories, and they have used deep learning techniques. And in that research paper, I have identified a computational complexity, very high, improper labeling, absence of high quality data sets, and model performance. And this is the last literature, Hugh Frecci and his team, they have developed on detection of COVID-19 from chest X-ray images. And they have used deep learning network and a few standard frameworks like ResNet 50, Inception v3, and VGG16. In that paper, I have identified the drawbacks like sensitivity to dataset quality, clinical integration challenges, limited validation and external setting, data augmentation limitation, etc. So I have compiled and common drawbacks I have identified from 200 papers: data imbalance, data set bias, limited generalization, high complexity, computational cost, interpretability gaps, privacy concerns, deployment overhead, and out of distribution, that is sensitivity and clinical dependency. So these are the challenges on that literature survey papers: data quality assurance, computational efficiency, interdisciplinary collaboration, ethical and privacy framework, generalizability and adaptability. And from that literature survey papers, I have framed the problem statement. And for detection of viral diseases are limited by slow processing, poor scalability, and difficulty in effectively integrating multimodal data such as text, chest X-rays, and CT scans. So current AI-based systems often fail to achieve an optimal balance between high diagnostic accuracy, model generalizability, clinical interpretability, and patient data privacy. That's why I'm using a unified deep learning generative AI decision support framework in order to avoid such kind of drawbacks, to improve the accuracies, scalability, interpretable, and real-time viral disease detection. And these are the 4 objectives I have framed with the help of my supervisor to develop a unified deep learning and generative AI-based decision support framework for accurate viral disease detection from 3 types of data sets like text data, chest X-ray, and CT scan images. To mitigate class imbalance and data variability, we are using a hybrid model on cross data set generalization to design a computationally efficient and scalable diagnostic pipeline suitable for real-time and resource constrained clinical environments. The last objective is to provide a foundation for future integration of privacy preserving by applying federated learning and explainable AI for trustworthy clinical deployment. These are gaps we have identified in existing system: limited data sets leading to weak generalization across various types of data sets like chest X-ray images, CT scan images. Many frameworks use complex modality specific pipelines that increase computational cost, hinder real-time deployment. And there is a research gap like class imbalance and cross data set variability are not adequately handled in the existing system, reducing sensitivity for minority and early stage access. That's why we are proposing a unified decision support system that is called a deep learning generative AI framework. that jointly ensure accuracy. We are increasing robustness, interpretability, and privacy are still lacking. So these are the standard benchmark data sets I have collected from GitHub and Kaggle. I will show you that the data sets. So far, I have collected two types of data sets I have collected from GitHub and Kaggle. So far, I have tested 56,000 images from standard benchmark data sets I have collected. These are the input data set images for chest X-ray images. And this is the second data set I have collected from other same repository with different data sets. And these are the three categories I'm classifying: COVID-19 virus, positive or negative, normal or viral pneumonia. And these are the CT scan images: COVID-19 positive CT scan for patients, non-COVID CT scan for patients. And this is the text database input I have tested with for my research paper publication. And these are the existing models I have used. In the existing literature review, there are AI-based diagnostic models lack robustness, scalability, and class imbalance, and consistent generalization across various clinical imaging settings on chest X-ray and CT scan and text-based. These are the drawbacks commonly identified from that 200 literature survey papers: high accuracy, less accuracy from that existing models, robustness, generalization, class imbalance, computational efficiency, scalability, clinical reliability problem. This one is changed. So to avoid those drawbacks, I am proposing deep learning and generative AI hybrid model on chest and CT scan images. And these are the proposed models. I have used 5 models as combinedly called a hybrid model with data augmentation and regularization, federated learning with explainable AI.
So Dr. Asadi, Asadi ji, you should change the previous slide. There is some confusion in that now.
Yes, sir. It is.
Because your proposed model is for avoiding these drawbacks.
Yes, sir. Yes,
you should write to avoid these drawbacks, right?
Yes, sir.
Maybe afterwards you change. Okay, next, go to next slide and continue.
Yes, sir. So these are the drawbacks. To avoid these drawbacks, we are proposing a hybrid model to improve the high accuracy, robust generalization, class balancing, computational efficiency, scalability, and clinical reliability. So these are the 5 models we have integrated with deep learning generative hybrid model framework. And this is the integrated framework for my proposed model for viral disease prediction, detection, classification. We are taking various data sets. We are applying CNN, RNN, transformer, and GAN. And we are integrating with the federated learning and explainable AI on chest and CT scan images, learning approaches on Kaggle and chest GitHub repositories. And finally, we are getting the 3 classification called COVID-19, pneumonia, and whether it is positive or negative, we are finding. These are the model architectures we are using: convolutional neural networks and vision transformers, recurrent neural networks, and a hybrid CNN RNN model. So in this model architecture, we are combining a hybrid generative and explainable AI-driven viral disease detection. For one research paper publication, we have implemented this model, and we got a 98.5 accuracy by combining various models. And these are the generative AI for data augmentation. We have applied cycle GAN, style GAN, and conditional GAN and evaluation. And the federated learning setup, we have taken 56,000 images. And for decentralized learning environment, multi-node setup, we have used client institutions and server augmentation, privacy mechanism, differential privacy. And in this explainable AI, we have used shapely additive explanation for feature importance analysis and live local interpretable model agnostic explanation and gradient weighted class activation mapping we have performed. So this is the three categories of data sets we have applied: chest X-ray images, CT scan, and text-based. By combining deep learning and generative AI models on viral disease detection. And finally, we are getting whether that the images are positive or negative. And these are the proposed hybrid algorithms. We are getting, we are combining so many models and making as a hybrid model to achieve these are the advantages. And this is again same. So these are the steps we have applied for a few architecture CNN, RNN purpose. And these are the experimental methodology we have used for data pre-processing. We have applied some techniques like rescaling and normalization, augmentation, resizing, edge detection. And this is the procedure we are following. Problem definition, data preparation, feature engineering. We are applying training, hybrid, deep learning, and generative AI algorithms, and testing trained model. Finally, we are getting model deployment. And this is the algorithm we are using, hybrid, deep learning, and generative AI algorithm. There are 20 steps we have followed by combining all the models for multimodal chest imaging classification. First, we are reading input arguments like data root, epochs, batch size, image size, and load chest X-ray image data set. Then we are loading CT scan data set. Then we are verifying class consistency on different imaging data sets. Then concatenate chest X-ray images and CT scan images. Then sixth step we are following, we are combining data set into train, validation, and test subsets. So default, I'm taking 70% for training, 15% for testing, and 15% for validation at the batch level. Then we are building pre-processing. Is there any noisy, inconsistent data? We are applying pre-processing techniques and like resize, normalize, binning, box plot, few more filtering techniques I have applied. Then apply pre-processing pipeline. Then we are applying, this is optional for generative adversarial network-based minority enhancements. Then 10th step, we are building the hybrid classifier model, use efficient net B0. So then we are adding a global average pooling plus dropout plus softmax classifier for head for multi-class prediction. We are compile the classifier using ADAM optimizer for increasing the efficiency, sparse categorical cross entropy loss and accuracy metric, set training controls for early stopping on validation loss, reduce LRO on lower training rate if validation loss. Then train for N epochs, we are increasing the number of iterations. First time I'm checking with the 20, 30, 40, 50 epochs. I have run my program. Then generate and save learning codes like accuracy, loss, epochs, and AUC, augment, and ROC, confusion matrix. These are the validation metric curves I have generated or evaluate on the test set. 15% of images I have used. I'm printing the classification report. Then we are computing confusion matrix, how much accuracy I got it. Compute micro average ROC curve, then plot and save all the existing versus proposed comparison. And we are finishing with all the saved output in one directory. This is the algorithm steps. For mathematically, we are my hybrid framework proposed work for validating whether my model is correct or not. I'm using some mathematical framework for viral disease detection. My proposed model is deep learning plus generative hybrid, the combination of various frameworks. And stepwise, I'm calculating with the mathematical proof for problem definition I'm using. for data collection, for data pre-processing, data splitting, then model architecture design purpose, then transfer learning, generative AI integration. I'm using these mathematical validation, mathematical proof, then model training and hyperparameter tuning for increase the accuracy for my proposed model. Then these are the evaluation metrics: accuracy, precision, recall, FN score, AUC, ROC. I'm checking whether my model is correctly classifying images or not. Then finally deploying with this one and the continuous improvement of my proposed model. I'm checking with latest inputs. And these are the experimental setup I have done. I have used a unified data set comprising 56,000 chest X-ray benchmark data sets. Initially, I tested with 20 epochs. Then finally, I stopped with 50 epochs. And these are the hardware configuration I have used. And these are the software libraries I have installed in my laptop. Like programming language, Python, latest version I'm using, deep learning frameworks, federated learning library, generative AI, explainable AI, image processing, medical imaging tools, data processing, security and privacy, deployment and cloud computing for storing of images. These are the tools I have used, frameworks, CNN, RNN, Transformer, generative models, GAN, explainable AI, SHARP and GradCam, federated learning for privacy. Data sets, I have taken benchmark data sets. And contribution one, what I have done in this unified accuracy optimized decision support framework, I have applied, and we are existing with state-of-art models in classification of accuracy across large heterogeneous X-ray and CT scan images. And the results validate the effectiveness of a unified framework in achieving high diagnostic accuracy. I got 97.8 percentile while maintaining robustness and clinical scalability. If you increase the size, it is running my system without any problem. Then contribution to, I have a generative augmentation driven class balance and robustness enhancement. In this contribution to, we have applied generative augmentation, significantly reduced class imbalance, leading to clear confusion matrices with minimal misclassification, because 97.8 we got, and still there are minimal misclassification across COVID-19, pneumonia and normal classes. And we are confirming AUC ROC 0.997, improved class separability and stable generalization across heterogeneous X-ray and CT scan images. And contribution 3, efficient decision support classification layer. In this one, still at highly reliable decision support classification layer that delivers class separation as evidenced by a clean confusion matrix with minimal misclassification. And still, we are confirming strong discriminative capability on ROC, AUC, and stable performance suitable for real-time clinical deployment. And these are the experimental results on hybrid deep learning and generative AI model. And I got a 97.8 accuracy, training and validation accuracy trends across epochs. And this is a training and validation loss trends across epochs. And this is a receiver operating characteristic distinguish between viral and non-viral cases, with the AUC 0.981 indicating excellent classification performance across all threshold values. And this is the time complexity, training time required per epoch, showing consistency, low and stable computational cost across epochs, which highlights the efficiency and the scalability for proposed model. And this is the confusion matrix shown to for accuracy purpose for classifying COVID-19, pneumonia, normal cases. And this is a training and validation accuracy versus epochs for a proposed deep learning generative AI decision support model. And This is by applying this deep learning generative AI decision support, training and validation loss over epochs, indicating stable learning, effective optimization, and good generalization of the proposed model. And this is the time complexity for epochs versus training time. So, and this is a training time on training time for confusion matrix and the same deep learning model. And this is existing versus proposed for accuracy comparison. I have applied 10 models for my research paper publication. I have used different models with a combination of TensorFlow, Keras, scikit-learn, and I got this is the accuracy. And my proposed model shows 97.8. And these are the results. These are the comparison of a split distribution for model training and evaluation. For training percent, 70%, I have used 39,200. And for validation purpose, 15%, that is 8,400 images. For testing, 15%, I have used 8,400. Then performance summary of my proposed model with existing. I got training accuracy 0.98 and validation accuracy 0.95 and average time 1.45 seconds for epochs. I have run 50 epochs. And this is the comparative performance analysis of existing and proposed viral disease detection. These are the models I have applied for my my research paper publication. I have used different models. I got different accuracies on different data set combinations I have used, and finally proposed here. Finally proposed deep learning generative AI decision support. I got 0.978 accuracy and F1 score and AUC. That is my proposed model got that is the on 56,000 images.
Mr. Asadi, can you go to previous slide? I mean, you are suggested to comparison slide.
Conclusion, sir.
Comparison, just now what you left.
Yes, this.
So you should actually cite the references of journal papers with whom you have compared.
Yes, sir. Yes, sir. At the last, I kept. Yes. Sir.
Comparison should be with respect to recently published journal papers.
Yes, sir. Yes, sir. I will.
You should write on the other Jaya published papers. Okay.
Yes, sir. Yes, sir. I'm noting down that comment, sir. I will incorporate published 5 published papers. I will incorporate in this
papers, recent journal papers.
Yes, sir. Yes,
quality papers. Huh?
Yes, sir. Yes, sir. Thank you, sir. Then this is the comparison of existing versus proposed system. And in existing system, approximately they have used 30,805, but I have used in my proposed deep learning generative AI system 56,000 images. Number of data sources, I have collected nearly Kaggle and GitHub and other repositories, 10 resources I have taken. These are the different parameters: F1 score, precision, accuracy, and recall. AUC, ROC, training epochs. I got in within 18 epochs itself, I got very good accuracy. Still, I'm improving to 50 epochs. Still, I'm doing on that part. And so this is the final comparison between existing versus my proposed model on benchmark data sets I have implemented. And these are the on 3 different data sets. I got 97.8% on test accuracy. And by integrating multimodal feature, I'm able to classifying pneumonia, positive, negative, normal images across various on healthcare settings. This is my future work. Still, I am working on by incorporating increasing size of the data set in online environment. Federated learning I am planning to integrate, and these are the references. And so last time, respected committee members asked, these are the questions, and these are the answers. I have standard data sets I have collected. Where is the standard data set? That question. This is the answer. Like from NIH chest X-ray images data set I have collected, and another one NIH chest X-ray data set I have collected, and these are the data sets. 125 GB data set I have collected, and these are the standard data sets from Kaggle, GitHub, etc. And these are the image data collection data sets. This is again a data set Kaggle repository, and this is one more Kaggle data set. And the second, in colloquium, committee members asked, these are the questions, 7 questions. I have incorporated all these 7s with answers. Latest data sets on viral diseases, AI classification for improved accuracy, novelty in my model. I proposed a hybrid model with deep learning and generative AI, accuracy model table, proposed model with results, retrained AI models for novelty, incorporation of latest data sets. And the third colloquium, committee members suggested these are the 6 questions. The first question by Anant Mohan sir, and second question also Anant Mohan sir, and Anjali madam also, why you have chosen 5 objectives, can you reduce them to 3? And Navjot sir, this question, I have incorporated all these comments into my research, and so these are my publications. First paper, IEEE conference paper published in the year 2023, and this is first I am showing my conference papers, and the Sprinter conference paper 19th July 2024 at MNIT. And this is one more Springer conference on my research topic. And this is recently in BITS Pilani with combination of IIIT Allahabad. They hosted this conference. I have presented 2 my research papers in this conference. So those papers are coming soon in Springer series. And this is one more conference in that same, this one in that conference paper acceptance. And this is my SCI paper published with my professor sir. This is Frontiers Journal. This is SCI paper. And this paper on overcoming diagnostic and data privacy, challenges in viral disease detection, and integrated approach using generative AI, vision transformer, and explainable AI, and federated learning. So here, if I click, so this paper published in Frontiers Journal. This is the paper, myself and Anupam sir. This is the paper, and next paper, next SCI paper. This is a UFDL, a unified federated in the same journal, Frontiers Journal. One more SCI paper I have published in that. So this is the Frontiers 2 papers, and 2 papers in +1 journal, and 2 papers in Springer Nature. I'm going to show. These are the publications.
Conclude, please.
Yes, sir. Sorry, sir. And this is the +1 journal, and in this, this is so we have submitted July 27th. Now it is already accepted with the major revisions. I have come. Now it is going to publish in this week. 2 weeks, November 15th, we finalized this paper. And this is one more paper. It's next generation federated and explainable vision transformer. This is one more paper submitted with major revisions, and this paper also coming next week. This is the paper, And this is a book chapter from IJA Global on my research topic, enhancing viral disease prediction and data detection using ECNN and ERNN technique. And this is scientific reports for improving CNN predictive accuracy in COVID-19 and that one. This is just UGC Care journal paper. And this is Springer Nature we have submitted. I have submitted with major revision, and still this paper is going to come. And these are the list of publications with my supervisor. 5 papers I have published in SCA journal, and these are the conference papers. One is IEEE and another one is Springer, 2 papers in Springer, and 1 more paper also in Springer. And this is a book chapter published in IGI Global USA. And I have started writing a textbook on generative AI applications using ML and DL techniques. I have started, these are the chapters, and these are the chapter headings, 13 chapters. And the work progress I am showing January to June 2025. This is the work I have done. And work progress July to December. This is the work I have done and submitted 4 more papers. It is in the pipeline right now. I have submitted under review. And next semester, I'm going to write a thesis. I'm planning to write with my supervisor. And this is a semester. This is the 4 objectives achieved with the help of my supervisor. I have implemented and submitted all the papers in reputed journals. And 7th semester, I'm going to start in January. This is my planning to submit. And thank you, sir, for giving me this opportunity. Please, any suggestions and queries, sir?
Asadi ji, actually, you should actually, because you are not in campus, you are doing from remote. You are working professionally.
Yes, sir. Yes,
so
sir. I will.
My suggestion is for all your published papers, you should keep.
Yes, sir.
You should keep the folder very safely,
Yes.
all the code, everything.
Yes,
and
sir.
It should be like somebody asked you to demonstrate.
Yes, sir. Yes.
Demonstrate with the same.
Yes, sir. Yes, sir. Sure, sir.
All the papers, whether conference or journal, you should keep the respective folders very safely.
Yes, sir. Yes, sir.
And you could be able to demonstrate the same results on the same data set with your respective code. You know?
Yes, sir. Sure,
that is
sir.
also very important.
Yes, sir. I'm writing down, sir.
So this is 3 or 4 suggestions I have given. Let me request my other honorable doctoral committee members to suggest to ensure quality in your thesis. In fact, one more suggestion I had given last time that you can see from this is Shodh Ganga, na? Some other recent
Yes.
PhD
Yes.
in that area.
Yes, sir. You have suggested a few more theses, sir.
I
So
sent
here,
I sent you 10 theses.
yes, sir. Yes.
So you should at least see in what
These are the
you
these
have.
are the 10 theses, sir. I have gone through all these 10.
So I had suggested you. I have sent you these PhD theses related to your topic.
Yes, sir. Yes, sir.
So
These are the PhD thesis papers you have sent, sir.
Yeah,
I kept in.
they are the thesis. So
yes, sir.
So you should actually include them in your as part of a literature survey also.
Yes, sir. Yes. Yes.
I mean,
Sure,
you
sir.
keep in your list, a literature survey list.
No, sir.
And also,
Sure,
I mean, try to highlight what novelty as compared to recently published doctoral thesis you have in your work.
oh, yes, sir. Yes. Yes, sir. Sure.
So, that is my suggestions from my side, and other members may kindly give some suggestions or ask some questions related to his presentation.
Yes, sir. Thank you, sir.
Hello.
Yeah.
Yes, sir, sir.
Saji,
Yes.
can you open the slide just before the conclusion?
Yes, sir. This one, sir?
Before the
Which one?
conclusion. Before the
Yes.
conclusion.
Yes, sir. Yes, sir. Sorry, sir.
You were showing some results.
Yes, sir. Yes. Sir.
This one.
Sir. Comparison, sir.
So if you
Yes, sir.
if you see the F1 score value,
Sir.
just cross check these values. So these values are incorrect for me.
Sir, sir.
F1
Yes.
score is the weighted harmonic mean between precision and recall,
Yes, sir.
where you are
Sir.
giving equal weightage to both precision and recall. So the values must lie between precision and recall.
Yeah, sir.
Your
Sure.
value is not in the range.
Yes, sir.
You see,
Sure.
0.988 is not between 0.93 and 97.
Yes, sir. Sure.
Similarly, if you check the second value also, it is not in the range. Maybe the
Yes, sir.
reason could be that since for individual datas, you would
Yes, sir.
have
Yes.
individual value of precision, recall, and F1 score,
Yes,
and
sir.
then you
Yes.
would have taken the average of precision, average of recall, and average of F1 score. That is what you would have done it.
Yes, sir.
So
Yes.
by default, it is like twice you have computed average, because F1 score
Yes.
is already an average, then you have taken more average.
Yes, sir.
So
Yes.
the better
Thank-
idea would be that you take the average of the precision, you take the average of the recall, and then using
Yes.
the formula of F1 score you apply.
Yes, yes, sure.
Otherwise, the value will be outside the range, so which is incorrect as per the definition of F1 score.
Yes, yes. Thank you,
Okay.
sir. I'm incorporating that suggestion, sir.
Make sure
So
that the results are as per the, range, as Dr. Navjot is saying. No?
sir,
Yes,
actually,
sir.
sir, what happens is whenever we do the training, so for every data we have precision, recall, F1 score.
Yes, sir.
At
Yes,
the
sir.
end, it shows the result of average precision, average recall, and average F1 score. So when you take average of average, so by default, F1 score may not lie between the range.
Yes.
So it is. So what we do is that we take average of precision, we take average of recall, and based on the formula of F1 score, you compute average F1 score. Then only it will come, because if anyone sees, then he'll say that it is incorrect.
Yes, sir.
Okay.
I will incorporate. Thank
Yeah.
you, sir.
So can you go to slide 89?
So this is slide 89, sir.
So may I know, like, why should I pick your model when VI Fusion X is giving me better results?
Sir, these are the models I have used for my research paper. Individually, I have checked this one, sir.
No. What I'm
And,
saying is, if there is an existing paper in the market which gives me better result than your paper, then why should I prefer your paper?
Which
Sir,
serial number, Dr. Navjot? Which serial number?
VI Fusion X. I think
yes, sir.
fourth from the last. Fourth from the
Yes, sir.
last.
Yes, sir. X-ray plus CT plus metadata, I got 98.997 accuracy.
Yes.
Sir, actually, I have this paper I have implemented on the combination of chest and CT scan with that. Sir, my proposed model. Sir, your question is why my proposed model is choosing, sir, here.
No.
Your proposed model is showing
No,
less accuracy. So Dr. Navjot is asking when
Yes, sir. Yes, sir. That is
VI Fusion dash X is having more accuracy, why your proposed model is having less?
sir, because
accuracy and F1 score also it is high compared to
yes.
your model.
Yes, sir. Yes, sir. I will recheck once again, sir, because I have used that less images for VI Fusion X. For
Or
that
you
one.
can compare with another parameter like either like computation at the
Yes.
computation if you are improving, or something
Yes.
other parameter which will you can show that your model is better than, because here whatever the parameter you are showing, your model is not resemble your model is better than VI Fusion.
Yes,
So
sir.
this is,
Yes.
I think.
Maybe you
Yes,
can
sir.
add number of parameters column.
Yeah, more
Where
parameters. So
you can
based
show that
on
in less number of
Yes.
parameters means your could be a lightweight model.
Mhm,
Then I
that
should go
one
with your
you can
model
do.
because there is not much in the degradation of the accuracy or F1
Yes.
score.
So Asadi, actually, whenever we are making comparative table, it is assumed that the data set is same. Otherwise,
Yes,
we
sir.
cannot compare. When we are comparing, it means that data set is same. So you are saying, Shad, I have taken less images. You should not do that. I mean, if you are comparing in the same table, data
Yes,
set,
sir. For the same image data set. Yes, sir.
make sure that all the data sets are same. Then
Yes, sir. I will cross check, sir. I will cross check these models for my paper implementation I have done, sir.
If
My
data
proposed-
set is same, then you have to compare with other parameter like
Yes. Yes,
latency.
sir.
You can compare then.
Yes, sir.
Number
Yes.
of images, whatever you are taking in training test.
Yes, sir. That
Epochs.
that I will cross check.
Yeah,
Thank you,
this
sir.
thing you can compare.
Yes, sir. Thank you, sir, for that suggestion. I will cross check once again.
Okay, so
But
can you go to slide number 87 now?
this is 87, sir.
You are saying that you have splitted the test data set 8400. You can slowly go to the back slides where you have shown in one of the slides the confusion matrix.
Yes, sir. This one, sir.
So is this confusion matrix related to that table which was there?
No, sir. But
Okay.
no. Yeah, no, sir.
Okay. So I was just confused because the sum was not coming out to be
Yes,
8400.
yes,
So
yes.
You have to make sure that all results are consistent. Okay. So
Yes, sir. Sure, sir.
Dr. Navjot is giving making observations, very quick
Yes, sir.
observations
Yes, sir.
on a very
Yes, sir.
short time. But you
Yes,
should
sir.
understand he is so, I mean, observative. Within a short time, he is making this observation.
Yes, sir.
So
Thank
you
you,
should
sir.
actually make sure that all the results, whatever showing, they are very consistent. You know?
Yes, sure, sir. I will make it, sir. I will make it according to my input size with the confusion matrix also. I will change, sir.
okay.
I
Okay.
will generate.
So one last question. You have used reinforcement learning somewhere. So how have you applied reinforcement learning for this particular topic?
Sir, sir, I have reinforcement learning. I have used while running my application, not showing correct accuracy, sir. Again, I modified with fine-tuning parameters, sir. That's why I called reinforcement learning, but exactly I haven't used, sir, reinforcement.
Actually, you have not used, you have applied, but I'm interested mainly in knowing, like, because for reinforcement learning, you have some states concept, you have some action concept, there's a Bellman
Yes,
equation which has to be applied. So I'm
yes,
just
sir.
worried, like, how did you manage to get hold of what is a state in your case? What are the different actions in your case?
Sir, for classification, sir, by applying reinforcement learning, sir, I'm not.
So that is
No,
what I'm
for
interested in knowing, like, how have you
classification,
applied classification
no, you
for
cannot use
reinforcement?
for the classification because this is a different kind of study.
Ah,
Like
yes, sir.
state and all this thing, you have to decide for the real-time decision making.
Yes, sir. Yes, sir.
So that kind of, I think if you are making some kind of model and at the real time it is taking the decision, then maybe you can use the reinforcement learning. But currently, whatever you did in this scenario, you cannot use them. As per my understanding, you cannot use.
Yes, sure, sir.
So either you are making a separate hardware model and you are making the decision based on that hardware model, then you can introduce. Similarly, the same question as
Yes,
Navjot sir also asked. You also explain the explainable AI also you are using in the beginning
yes,
when you
yes,
started the presentation. But
yes, sir.
I didn't see any slide related to that.
Okay, sir. One
So,
of the paper I have used, sir, actually,
hmm.
but I haven't incorporated. Sorry, sir. I will incorporate that one.
Because again, if you will use any hardware model and you are taking the reinforcement learning, then after that you can use the explainable AI.
Yes, sir. For running.
The next step after that.
Yes, sir. By running my huge volume of data in federated learning on decentralized environment, then I can consider. Yes, sir.
By the way, you have multiple publication. Everything is good, and your literature survey also very good.
Thank you, sir.
Yes, but whatever you are proposing, or you can say, we will as a future scope you can show.
Yes,
This
sir.
thing
Sure.
you can show as a future, not in this because you mentioned that you are using all this thing in the beginning.
No, sorry. Sir. Okay,
So
sir.
whatever you are claiming that you have used, actually the members want to, you should have proper illustrative diagram, architecture, how you have used. Clarity should be there. If you are claiming that I have used reinforcement learning and explainable AI, all these things, so it should be, I mean, proper proof should be there how it is
Yes,
going to be
sure.
used. You know?
Otherwise, put into the future scope and it is okay.
Yes, sir. I will change according to your
He,
suggestions.
he will improve on his work because
Yes,
it's
sir, definitely because
he has 6 months work, so at least minimum
he
for
can improve. Sir.
so he can improve on
He
it.
has a good literature survey actually. So many papers he already made. Okay, good.
Thank
Good. Okay.
Thank you, sir.
Okay, Asadi, I have some queries.
Ma'am, please.
Like in your data set, what kind of images were there?
So,
What was
madam,
the image format?
these are the image format JPG images, madam. 1 second, madam. I'll show you my data sets. This is a data set. For training, I have used these are the JPG images, madam.
And for CT, this is
Yes,
X-ray image, and for CT, what was the format?
same JPG, madam.
But you should not take JPG. It is not acceptable format if you are working in medical imaging and especially CT scan.
Ma'am.
See, it is not the JPG format.
Yes.
So how you have worked on this data?
Madam, I have.
This is dot. What is the name of this file?
Yeah,
.nii.
yeah, that is one organization given that standard data set I have taken as
So
it is,
what is the
madam.
name of that format?
NIA, madam, that is organization name, madam. They kept it like.
No, we generally call it as Nifty images.
Oh, sorry.
So it is not a CT image. How you have extracted Nifty? Because there is a different format way to
There
extract
is,
these kind of.
there is, yes, there is a function in Python programming, madam. I have converted that function, madam.
So in your one image, how many slices were there?
3 slices, madam.
For one patient, there is just 3 slices.
Madam, in the data set I have shown in the input data sets, madam. Here I have shown slices. Here, madam. Here slices.
You know what is slices?
Madam, in that image categories, madam.
No, you don't know then what is slice. You please find out what
Yes, sure,
how
madam.
actually these images worked on. Because you
Yes.
have published the paper, so I thought you should have know about that.
Yes.
And one thing I have observed in your publications, you have published 5 papers,
Yes,
and
ma'am.
the results which you have shown here to us, okay,
Yes, madam.
are these the published works? Are
No,
these
madam.
in the published?
Those papers work is the same, madam, but the images are I have taken less for the publication, madam.
So results are different on the published work, and
Yes.
results are different on the slides which you are showing to us.
No, now I'm this is final work, madam. These papers will come next, madam.
So
Now,
the results which you have shown to us have not been published till now.
yes, madam. Yeah, these
Okay.
results. I'm taking all the suggestions and I'll incorporate. Then I'm going to publish this work, madam. This is current work.
Okay, one last question. Please go to your
Thank-
publication slide.
Yes, madam. This one, madam.
I have observed that these frontier in virology and radiology, these are the open access journals, right?
Yes, madam. Yes, ma'am.
All the journals where you have published are the open access.
Yes, ma'am. Yes, ma'am.
Why you haven't tried with the non-open access means where you don't have to pay anything?
Madam, yeah, yes, madam. I 2 papers are in that pipeline, madam. No money, no.
Because
It is
here
not.
all the published papers, all these are, all 5
Yes.
are the open access, means you have to pay something, I think around more than 1 lakh.
Yeah,
Right?
madam. I have one privilege, madam. I have utilized that privilege, madam. Earlier, I worked in one country called Liberia, madam. So I have in that organization, I belongs to low income country, madam. So I'm using that credentials for publishing these papers, madam.
Okay, but fine. For the next time when you are going to
Sure.
come,
Yes,
try
ma'am.
to publish with the non-open access
Yes,
journals.
I
Okay.
have already submitted, madam. Waiting for comments, madam.
Okay, then fine. This is what from my side.
Yes, thank you, ma'am. Thank you, ma'am.
So,
I will incorporate all these comments, madam.
Asadi ji, please make sure that your published results and your reported results, they match. And
Yes.
when you are comparing them, they are on the same data sets. Otherwise, the comparison doesn't make any sense, isn't it?
Yeah, sure, sir. I will.
Please make sure that, and also as Madam has suggested, it is better to have publication in non-open access journal also where there is no fee. Okay.
Yes, sir.
There
Yes,
are good
sir.
journals in your area. you should
Yes.
discuss and work on.
Sure, sir. Sure, sir. Sure, sir.
So I think any other questions? Then otherwise we can bind up. Is it okay for every side? I will actually ask them to quit. Then we can have just 2 minutes discussion. So should I ask Asadi and other members to quit?
No,
Yes,
sir.
sir.
No, I don't have any questions, sir.
So Mr. Asadi and other people who have joined, please quit so that we can have some discussion with the members.
Thank you, sir.
Yes, Ashutosh and others, they may quit. Anil, you can quit.